Welcome back, builders, to another explainer in our 50-day O-Level Practical Challenge series. Grab your hard hats and drafting tools, because today we're stepping fully into the role of web architects. We're moving way past basic text and static elements to build highly dynamic HTML5 structures. We're going to be wiring up these pages with audio, video, and hidden interactive geographies. It's going to be awesome.
Think about it. Yesterday had us laying down the concrete with interactive registration forms, pure static input gathering. Today, at day 06, we're hitting a massive milestone. We are injecting life into our projects with HTML5 multimedia and image maps. We're building that dynamic infrastructure modern users absolutely expect, and honestly, it sets the perfect stage for tomorrow, where we finally bring in that visual polish.
So here's our blueprint for today. First, static foundations and accessibility. Second, embedding native HTML5 multimedia. Third, mastering HTML5 image maps. Fourth, plotting coordinate target geometries. And fifth, synthesizing the dynamic page.
All right, Section 1, Static Foundations and Accessibility.
Okay, before we even touch the flashy video elements, we've got to talk about images and the vital safety nets that absolutely have to accompany them. I literally cannot emphasize this enough. This is a massive examiner checkpoint for the NIELIT practical. Accessibility compliance? It's not optional. If you forget your alt attributes, screen readers for visually impaired users just completely fail. And guess what? Examiners will absolutely deduct points. In the real world and in this exam, ignoring accessibility breaks your structural integrity. Just don't do it. Just look at the syntax. You've got your source pointing to the image file, but right next to it is the alt attribute reading Jupiter with moons. This acts as an invisible scaffolding. If the image file breaks, fails to load, or, like we just said, gets interpreted by a screen reader, this text is your critical safety net. Never, ever build an image tag without it.
Moving on to Section 2, Embedding Native HTML5 Multimedia.
Think about the sheer power of a single word in HTML. By simply adding the word controls inside your video or audio tags, you're giving the browser a direct, powerful command. Without writing a single line of complex JavaScript, controls magically generates the whole shebang: the play button, the pause button, the timeline slider, and the volume settings. It's just incredibly efficient architecture.
Now, this matrix brilliantly breaks down how we handle these different media types. An image tag? That's a self-closing tag. But audio and video, they are container tags. You have to open them and close them. Why? Well, because they need a much more complex fallback strategy. An image just falls back on its alt text, right? But audio and video containers need to hold multiple source files inside them to make sure they actually work across every single browser out there.
You can think of the browser's internal fallback logic like a mission-critical decision tree. First, it tries to load the MP4 codec. If it succeeds, boom, it hits play. But if it's unsupported, it doesn't just crash. It moves down the tree and tries WebM. Still no luck? It tries OGG. And if absolutely all of these formats fail, only then does it render the absolute fallback text you've written inside the container, saying something like, your browser does not support HTML5 video. It's an elegant, foolproof system.
All right, Section 3, Mastering HTML5 Image Maps.
This is where we turn standard static graphics into multi-link navigation hubs. We're basically hacking the image. Take a standard graphic of Earth and the Moon. To the user, it's just a standard JPEG. But as web architects, we can plot invisible geometric interaction regions right over the pixels. We can literally draw a massive invisible rectangle over the Earth and an invisible circle over the Moon, turning specific parts of one single image into completely distinct clickable links. It's like magic.
But to make this magic happen, we need a connectivity bridge. Inside the image tag, there's an attribute called useMap set to #planetmap. That hashtag? It's absolutely everything. It wires the visible image directly to the invisible coordinate map defined right below it. Without that exact matching name and that little hashtag, the visible and the invisible never, ever talk to each other.
Section 4, Plotting Coordinate Target Geometries.
With our bridge built, we need to understand the geometry, because the browser needs different instructions depending on the shape. To define a clickable rectangle, the browser just needs 2 points in space: the X and Y coordinates of the top left corner and the X and Y coordinates of the bottom right corner. It just fills in the rest. But for a circle, you can't really use corners. The browser demands the absolute center coordinate, the exact middle X and Y, followed by the length of the radius to draw that clickable boundary outward.
This shape and coordinate diagnostic is essentially your cheat sheet. These are the literal formulas you'll need to memorize and punch in for the exam. For a rectangle, shape equals rect uses x1, y1, x2, y2. For a circle, shape equals circle uses x, y, r. Lock this blueprint into your brain. Whenever you see an image map question, just pull up these specific syntax rules and map them straight to your image dimensions.
Finally, Section 5, Synthesizing the Dynamic Page.
We've gathered all our materials, we've learned the individual techniques, and now it's time for the visual climax of our blueprint. The Abstract Document Object Model, or DOM tree, is the browser's internal blueprint. You have the body tag holding the video, audio, and image tags. Notice that crucial architectural link connecting the image node to the map node, which holds those geometric shapes we just talked about. This invisible blueprint directly translates into the final browser render, interactive media players with their native UI, and an image fully layered with our hidden clickable regions.
To make sure you execute this flawlessly under pressure, I want you to treat this NIELIT portal step logging procedure like a strict pre-flight checklist. Step 1. Initialize your boilerplate HTML5. Step 2. Build your image tag and never forget your alt text and your use map attribute. Step 3. Define your map and plot your area shapes. Step 4. Embed your video container, complete with those fallback source tags. And finally, Step 5. Execute, save the file, and verify every single click and play button right in the browser.
Which brings us to your mission. Your homework challenge is to build a unified dynamic media page using everything we've constructed today. I want one functional video player, one functional audio player, and a space scene image mapped with at least one rectangular and one circular clickable region, all correctly linked via href. Nailing this proves your complete mastery over HTML5's dynamic media matrix.
And with that, we can officially commit our progress. Day 06, media and maps are complete. We have successfully built a robust, highly interactive, and totally accessible HTML5 foundation. The structure is solid, the media is playing flawlessly, and our invisible navigation maps are perfectly plotted.
But let's take a step back and consider what we've actually built. The elements are highly functional, for sure, but they are visually pretty raw. We've got the bones, we've got the wiring, but the presentation is entirely dictated by the browser's default, kind of boring settings. So I'll leave you with this provocative thought. We've mastered the structure, but how do we take total control of the design? How do we make these dynamic elements actually look beautiful, customized, and professional? Well, that is exactly what we're going to uncover next, when we unlock the incredible power of styling. Keep exploring, keep building, and I'll catch you in the next explainer.